Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today we have set our hearts to solve a theory paper. We call it paper 2, and we have selected October-November 2022. 2-1 paper. This paper 2 belongs from the zone 1 or the variant 1. In this video, we are going to attempt the section A of this paper, and let's start this paper. So here we go. This is October-November 2022 2-1 paper, the section A of this paper. So section A, question number 1, figure 1.1 shows a steel spring. Describe an experimental procedure for obtaining the results needed to plot an extension load graph for this spring. To plot the extension load graph, so first of all, what we do, we will take a retort stand, and with that, we will hang this spring, and we will use a vertical scale, and we will measure what is the length of the spring. We will call this unstretched length. We will represent it with the L0. Then we will hang with it a 1 Newton load, and we will note down the length of the spring. We will call it L1. So by using the formula, extension is equals to L1 minus L0. We will calculate the extension. Then we will increase the load to 2 newtons, and we will note down the length. We will call it L2. We will calculate the extension. That will be L2 minus L0. In the same way, I will gradually increase the load to 10 newton, and I will add, each time I will give an increment of 1 newton load, and I will note down the extension. Then I will plot a graph between the extension and the load. The load will be taken on the x-axis, extension will be taken on the y-axis. I will plot the points on the graph, and then I will join them. And this is how you will get the extension load graph for this spring. It's a 3 marks question. I have written this answer also. So let me show you my written answer. Okay, hang the spring with a stand, measure the length of the spring with a vertical scale, L0. The length will be L0, unstretched length. Hang 1 Newton load with the spring, measure the length of the spring, and we will call it L1. Calculate the extension by subtracting L0 from the L1. Hang 2 Newton load with the spring and calculate the extension. Then increase the load gradually, and for each load, calculate extension. Draw a graph by taking extension on the y-axis and load on the x-axis. So this is my answer, the marking scheme of the question number 1, part A. He says, measure the length, attach marker, attach load, and measure new length, and calculate extension, or attach load and read extension using marker against 0 rule. Obtain a new rule result for different load, or use ruler or calculation of the extension. Explain. Okay. So then we have the question number 1. It's B part. In an experiment to obtain results for an extension load graph, a spring is stretched beyond its limit of proportionality. On the figure 1.2, sketch the extension load graph for the spring. So they have stretched it beyond its limit of proportionality. Up till the point of proportionality, the graph will be a straight line with the positive gradient, and after you cross the limit of proportionality, the graph will curve upward. Let me show you. So here is the solution. This is point of proportionality. Up till this point, the graph is a straight line between the extension and the load, which means extension and load, they are directly proportional to each other. And after the proportionality, limit of proportionality, the graph will curve upward, which means the extension has become easier. Extension and load, they are no more directly proportional to each other. Straight line of positive gradient from origin, and for at least half of the drawn line, curve of increasing gradient starting at the end of the straight line, or never becomes vertical. Okay. So our answer is right. That was the solution. He says on your graph figure 1.2 mark and label with the P, the limit of proportionality. So we have done that. I can show you. This is the P. The limit of proportionality for this spring occurs at a load of 8.5 Newton. The extension of the load is equal to 0.014 meter. When the load is equal to 3.5 Newton, calculate the extension for a load of 5.5 Newton. Very simple. You see, extension and load, they are directly proportional to each other. So I'm going to use the method of proportionality. And here is the solution. Load and extension, 3.5 Newton. The okay. So when the load is 3.5 Newton, the extension is 0.014 meter. When the load is 5.5 Newton, how much is the extension? This is called the method of proportionality. So I will write them in the ratio. So 3.5 by in the fraction. 3.5 by 5.5 is equal to 0.014 divided by x. So cross multiply. So 3.5x is equals to 0.014 multiply 5.5. And x will be equal to, this will go on the other side, it will divide. So 0.014 multiply 5.5 divided by 3.5, you get 0.022. So the extension at 5.5 Newton will be 0.022 meter. 0.022 meter. The answer, our answers are right. This is the solution. A child's toy consists of a flexible track and a model car. Figure 2.1 shows a diagram of the toy. So here is the position A, this is the position B, this is C, this is D, this is track, this is E position, this is F position. There was some problem. There was some issue with the internet due to which, so let's read it again. Question number 2, a child's toy consists of a flexible track and a model car. Figure 2.1 shows a diagram of the toy. So here we have that track and the toy car. The child first holds the car stationary at point A, which is 4 point. Okay, the child first holds the car stationary at point A, which is 0.45 meter above the horizontal section of the track BC and FG. The mass of the car is 0.12 kg. The child then releases the car, which travel towards the point B. Both air resistance and friction between the car and the track are negligible. So you see, this sentence is very important. Okay. So both air resistance and the friction between the car and the track are negligible. The gravitational field strength G is 10 newtons per kg. Calculate the change in the gravitational potential energy of the car as it travels from A to B. Okay. So as the car goes from A to B, the vertical height which it loses is 0.45 meter. So the gravitational potential energy which it will lose, that will be equals to mgh. So the gravitational potential energy loss will be equal to mgh. The m value is 0.12 kg. The g value is 10 Newton per kg. The height which it came down is 0.45 meter. So just multiply them, you get 0.54 joules. 0.54 joules. So that's the right answer, sir. Solution. Question number 2 and its B part. Calculate the speed of the car when it reaches the B. So you see, when this car from A here, it has purely gravitational potential energy. When it will come down to B, all its gravitational potential energy will convert into the kinetic energy. And so the gain in the kinetic energy at the point B will be equals to the loss in the gravitational potential energy at the point A. So at the point B, sorry. And so this is the basic idea on which this solution will be done. The gain in the kinetic energy will be equal to the loss in the potential energy. So the kinetic energy will be equal to the 0.54 joules. So kinetic energy is 1 by 2 mv square. So that is equal to 0.54. And v square will be equals to 2 multiplied 0.54 divided by 0.12. And so v square will be equals to 9 and v will be equals to 3 meter per second. So the velocity will be 3 meter per second. So our answers are right. This is the solution. After releasing it, the child expects the car to follow the track along the route A, B, C, D, E, F, G. In fact, the model car does not reach F. Explain in terms of energy why the car does not go past D. Why the car does not go past D, which is also 0.45 meter above the track. Okay. So the answer is very simple. Let me explain you from the diagram. You see, from here, when the car reached here, so it has 0.54 joule. Yeah, that was the energy. Yeah, 0.5. Here at the point B, the kinetic energy is 0.54 joule. So because there is no air resistance, because there is no friction between the tires and the track, so there is no loss of energy. So at the point C, the kinetic energy will be again 0.54 joule. At the point D, whose height is same as that A, the gravitational potential energy will be 0.54 joules. So when the car will go from C to D, all its kinetic energy will be converted into the potential energy. And the car does not have more energy to go past the D point because it does not have any more energy. It has just enough energy to reach the point D. So my answer is the potential energy at the D will be 0.54 joules. Car don't have enough energy to go past D. Its energy will become 0. Okay. So this is the question number 2C, one part. So the answer is here. You can read that, pause video, check the answer. I have already checked this. Okay. I hope you understand what I'm saying. This word is very important. Immediately after being released at A, the car travels to B, to C, and then to D. Describe the motion of the car after it reaches D. So when the car reaches the D, its kinetic energy becomes 0. So it cannot go past the point D. So what will happen? It will go back. So from D, it will go to C, to B, and then again to A. So at the D, the kinetic energy will become 0. So car will go back to C and B, and then it will go to A. This is my answer. It travels back down to C and returns to A. So our answer is right. So I hope you understand, and we are going to the next question. The next question coming up on your screen is question number 3. He says a curved glass tube is open at one end and sealed at the other. A dense liquid is poured into the tube. The liquid traps air in the sealed end. Figure 3.1 shows the tube, the liquid, and the trapped air. Okay, so here we have that trapped air, and the length of the column of the trapped air is x. And this is the level, the difference of the level in both the limbs of this U-shaped tube. Of the liquid, the level of the liquid, this is the difference between them, that's H. And they say the difference between the liquid levels in H at room temperature, H is 0.57 meter. The density of the liquid is 1.4 expo 4 kg per meter cube. The gravitational field strength G is 10 Newton per kg, and the atmospheric pressure is 1 expo 5 Pascal. Calculate the pressure of the trapped air. So the pressure of the trapped air, I can tell you from here. The pressure of this trapped air is H meter more than the atmospheric pressure. because the level of the of this liquid, I'm saying mercury, of this liquid, he has not said it's mercury, but normally it's mercury. So it is the trapped air here, the pressure of that trapped air is H more than the atmospheric pressure. Okay, so that's my, so the pressure of that air will be the atmospheric pressure plus the rho gh. Rho gh is the pressure of that liquid of that height. So it will be 1 expo 5 Pascal plus 1.4 expo 4 multiply 10 multiply 0.57. So you will have 1 expo 5 plus 7.98 expo 4, and that will be 1.798 expo 5, and it will be 1.8 expo 5 Pascal. 1.8 expo 5 Pascal. 1.8 expo 5 Pascal is the right answer, sir. This is a solution. This is my solution. Okay. So question number 2, three. Question number 3, and it's B part. The trapped air in the tube is heated. The height of the trapped air in the tube is x. Explain in terms of molecules why x changes when the air is heated. You see, when you will heat that air, the molecules of that trapped air, they will absorb the thermal energy and they will start moving faster. So when they move faster, their kinetic energy increases. So their collision frequency with the walls of that tube and with that liquid surface, that will increase. And when they will be hitting with the walls of that tube and the surface of that liquid, because now they have more kinetic energy, they will exert more force, the molecules of that air. So due to that, a larger force per unit area will be exerted on that liquid due to that air. So the pressure of that air will increase. So that's why that liquid will go down and the length of the X will increase. These are my reasons. So when the trapped air is heated, its molecules start moving faster. Their kinetic energy increases. They collide more frequently with walls of tube and mercury. I said mercury, they have not used the word mercury. They are saying only liquid. Okay, so you can use the word liquid. Air molecules will hit harder during these collisions. Pressure of the trapped air will increase. So the mercury will move down. X value will increase. So this is my answer. Air molecules speed up and they hit the liquid surface harder or hit the liquid surface more often. Increased extra force on the surface of the liquid or air pressure increases. So I hope you understand. Question number 3B, second part. The trapped air reaches a constant temperature that is greater than its initial temperature. Describe and explain the change in the H in terms of the pressure involved. So when the X value will increase, you see the level of the mercury in the right side of that tube, that will go up, and the level of the mercury or that liquid in the left side, that will go down because the X value increase. So here the level of that liquid or mercury will go down. In the right side it will go up. The H value will increase and it will continue to increase until that point when the new pressure of the air trapped, that pressure is balanced by the atmospheric pressure and the pressure of that liquid, which is represented by that difference of the level in both the limbs. So let me show you my answer. I have written this answer. It's a little tricky question. The wording is very tricky. Because the pressure of the trapped air has increased and pressure difference between trapped air and the atmosphere has increased, the value of the H will increase. Pressure of the H meter of the Hg, I have used the word Hg, you can use only liquid, and the atmospheric pressure balanced with the pressure of the trapped air. So that is my answer, and this is the answer given in the marking scheme. As the liquid moves, as air volume increases, difference between liquid level H increases. Eventually, pressure balance becomes equal, stays balanced. So this will happen until the pressure of the atmosphere plus the pressure of that H length of that liquid that balances with the pressure of the trapped air. So I hope you understand. Question number 4. X-rays are transverse waves that are part of a spectrum of waves. State the name of the spectrum of waves that includes X-rays. That spectrum is called electromagnetic spectrum. That is called electromagnetic spectrum. And here we go. The answers are coming from question number 4. Electromagnetic waves, the component for electromagnetic spectrum. Okay. So our answer right. Question number 4B, first part, explain what is meant by frequency. Frequency means the number of waves passing from a point in unit time. Or you can say the number of waves, complete waves passing from a point in 1 second. The unit of the frequency is hertz, and number of complete waves passing from a point in unit time is called frequency. Number of oscillation cycles, wavelengths per unit time. Okay, so this is my solution. Question number 4B, second part. State the name of the waves in this spectrum that has the greatest frequency. So they are talking about the electromagnetic spectrum, and you remember the electromagnetic spectrums. We remember it by Ronald McDonald is very ugly except Gary, which means radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. The highest frequency gamma rays have. So from this electromagnetic spectrum, the highest frequency is that of gamma rays. So gamma rays have highest frequency. So the answer is gamma rays. Then the question number 4C is first part. He says X-rays are used in hospitals to produce an image of broken bones. Explain how this is done. You may draw a diagram if you wish. It's a 3 marks question, a very famous question. Okay, so what we do, we take a emitter of the X-rays, we take a detector of X-rays, normally it's a photographic film, and between the X-ray emitter and the detector, for example, if you want to take the X-ray of your hand, so we place the hand between the detector and the X-rays emitter. So the X-rays, they can very easily pass through the flesh, but the X-rays cannot pass through the bones. So through the flesh, the X-rays will reach on the detector, and through the bones, they cannot reach. So the X-rays, they will affect the photographic film. So when you will develop that photographic film, you will see where the flesh is, the photographic film will become black. And where there are bones, the photographic film will be white because the X-rays are unable to reach at that region to onto the photographic film. So if there will be any crack in the bone, so what will happen through that crack, the X-rays will pass. So in that white bone on the photographic film, wherever there will be a crack, a black line will show up, which means that through this crack, the X-rays have passed. So that means there is a crack. So this is how the X-rays are used to detect the broken bones. So here is my answer. So figure 4C, first part. So here we have the emitter of the X-rays. Here we have that hand whose X-ray we want to do, for example. And here's the detector of the X-rays, which is normally a photographic film. Emitters emit X-rays. X-rays can pass through flesh. X-rays cannot pass through bone. Body is placed between emitter and detector of X-rays. Detector detects the X-rays and bones appear white on photographic film and the flesh appears black. If bone has crack appears black in white bone on the photographic film. So I hope you understand what I'm saying, and let's see. So he says the X-rays is directed towards body part with the suspected broken bone. X-rays pass through flesh, but not to same extent to the bones. The image produced by digital electronic CCD or CMOS detector. So now we also use the digital imaging, but in previous cases in Pakistan nowadays, still we use that photographic film. But we can have the digital imaging also. So this is the answer in front of you. So, okay, so explain, this is the question number 4C, second part, explain why X-rays are not used for prenatal scanning. You see the X-rays are very, they have energy in them, their frequency is very high. So they have energy. So we do not use them for prenatal scanning because the X-rays cause cancer. They are harmful for the baby. You can say that. The X-rays can cause cancer. They are dangerous, okay, for the infant. He says the X-rays cause cancer, cell mutation, birth defect, miscarriage. X-rays show the bone structure rather than fetal development, or image would not be clear. Okay, so this is our answers. Question number 5 is on your screen. It says figure 5.1 is a diagram that shows the number of particles in a charged atom, ion of the beryllium. So here we have 2 electrons in the outer shell. In the inner shell, this is the nucleus. We have protons and neutrons. And he says the charge on an electron is minus 1.6 expo minus 19 coulomb. The charge on the ion is 3.2 expo. There was some issue with the internet, so the connection disconnected and it has resumed recording again. Sorry for that. This is happening. Okay, figure 5.1 is a diagram that shows the number of particles in a charged atom or ion of the beryllium. So we have 2 electrons in the outer shell here, and there are 2 shells. There are only 2 electrons right now. The charge on an electron is minus 1.6 expo minus 19 coulomb. The charge on the ion is positive 3.2 expo minus 19 coulomb. This number is very important. This is the charge on one electron, and this is the charge on that ion. So I will divide I will divide this with this, and I will find out how many electrons are there, how much electrons deficiency is there. Because you see, this is positive, the charge on the ion is positive. So that means the deficiency of electron is there. So deduce from the charge on the ion the number of protons in its nucleus. Show your working. Okay. So first of all, I will find out how many electrons are deficient there, and 2 are already there. So let's find out. So the charge on the electron is minus 1.6 expo minus 19. The charge on the ion is 3.2 expo minus 19 coulomb. So number of the protons, that will be equals to the two electrons there, and how many electrons this give us? That's 3.2 expo minus 19 divided by 1.6 expo minus 19. That is 2. So there are totally 4 electrons. So it means there will be in a neutral atom, there will be I mean, no, even in this sign, the proton numbers are still that will be 4. So the proton numbers in the neutral atom is, and the proton number and electron number, they are equal to each other. So basically I have found the electron number, and so it means in the nucleus the proton numbers are 4. So there are 4 protons. A little tricky thing, 4 proton numbers. Okay, so there are 4 proton numbers. Okay, then we have, he says, question number 5. It's A and its second part. Write down the nuclide notation, the symbol for the nucleus of this charged atom. Okay, so it will have 4 protons and 9 neutrons. I have just counted them. So number of nucleons means how many particles are in the nucleus. They are 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of nucleon number is 9 and the proton number will be 4. So our answer is right. Then the question is question number 5, B part. The isotope in the figure 5.1 is the only stable isotope of beryllium. Explain the term isotope. Isotopes are atoms of an element who have the same proton number, but their nucleon number is different from each other. And the nucleon number is different because they have different number of neutrons in their atoms. Isotopes of an element are atoms which have the same proton number but different nucleon number. So a form of an element with a particular number of neutrons and nucleons. Okay. Then the question is the C part of question number 5. He says, explain what prevents electron in an atom from escaping. You see the electrons are in orbit and they are negatively charged, and the protons, they are positively charged and they are inside the nucleus. The proton are positive, electrons are negative, so they have electrostatic force of attraction. So that electrostatic force of attraction keeps the electrons in the orbit. Electrons are negatively charged, nucleus is positively charged due to protons. Oppositely charged particles attract each other. So due to that electrostatic force of attraction, the electrons keep moving around the nucleus. Electrons and nucleus opposite charged, or electrons negative and nucleus positive, electrostatic force of attraction or unlike charges attract. Okay, so then we have question number 6, and he says an electromagnet is used to separate objects that are magnetic from objects that are non-magnetic. Figure 6.1 shows the electromagnet suspended from the arm of a crane. Okay, so these are the scrapyard cranes, and so this is electromagnet. It will pick up the magnetic material from, or you call it scrap. State the name of the metal from which the core of the electromagnet is made. Electromagnets are normally made from the soft iron. Soft iron. Soft iron. So here's the answer. Yeah, soft iron. Then the question is, the electromagnet is powered by a 220-volt DC direct current supply. The electromagnet is switched on and the current in the circuit is 39 ampere. Calculate the power transferred to the electromagnet. The formula for the electric power is equals to IV. We have the value of the voltage, we have the value of the current. So power is equals to IV, that's 39 ampere multiplied 220 volt, and that will be 8,580 watt. This is the answer. Our answer is right. So it will be 8.6 expo 3 watt. So our answer is right. So. Okay. Then we have the DC supply is a set of batteries. The batteries power the magnet for 4.5 hours before they need to be replaced. Calculate the charge driven around the complete circuit in this time. Okay, so I know the amount of current, I know the time. So I can tell you the charge I is equals to Q by T. So the Q will be equals to I multiplied T. I is 39 ampere and the time is 4.5 hours. To convert this into seconds, I will multiply with it 3600. And so the final answer will be 6.3 x per 5 coulomb. 6.3 x per 5 coulomb. 6.3 x per 5 coulomb is the right answer, sir. This is the solution. On question number 6 and its C part, he says, on a very cold morning, the electromagnet is first switched on. The current is greater than 39 ampere before decreasing to the usual value. Explain why the current is initially greater than 39 ampere. You see, he's saying on a very cold morning. So when you switched on the crane, you see, because of very low temperature, the resistance of the coil in that electromagnet, that will be quite low because of the low temperature, and due to that the current that coil will take from the power supply, that will be more than 39 amperes. But as the crane starts work, or the the temperature rises due to the day, the resistance also rises and the current will come down to 39 ampere. So when the temperature is lower, resistance of coil, which is in the electromagnet, is lower. So larger current will flow in the coil. Resistance increases with the temperature, resistance lower because of the low ambient or the temperature. So I hope you understand. Our answer is right. And so we have reached the, okay. So now, my dear students, we have, in this video, we have solved the paper October-November 2022, Physics 505421, Section A of this paper. There were 6 questions in the Section A, and we have given you the solution of all these questions. The Section B of this paper I will solve in my next video, and you will also find the link of that video of the Section B. Soon I will upload that video, and I will paste the link in the end cards, and also you can find that in the playlists of my channel, because the Section A of the Zone 1 Paper 2 is a separate playlist, and the Section B of the Zone 1's Paper 2, that's a separate playlist. So Section A will be in a separate playlist, Section B will be in a separate playlist. So just if you are watching this Section A and you want to see the Section B, and you can find that video in that playlist. I will also paste the link of that video. So if you find this video useful, interesting, and it has helped you, please like this video, share the link of this video onto your Facebook, onto your Instagram, and onto your Twitter accounts. I think it's a great blessing for me that I can make these videos and I can touch the life of so many students around the globe. Thank you very much. Have a great day. God bless you all.